Hello, everybody, and welcome to today's lecture. So last time we talked about 1.1. Um, I posted the video for that, and I can't remember if I did, but I will post the notes for that as well. So just it was mainly just definitions like sample, populations, probability, statistic, parameter, variable, data, that kind of stuff that we're going to be talking about throughout the semester. So I was going over 1.2, and at first glance, it looked really long, but there's a lot of stuff that we're going to kind of glance over. So it's not actually going to take very long. So we'll probably do 1.2 and 1.3 today. Um, but let's just jump into it and see how far we get. So this section is about data in a general sense. Okay, so last section was about definitions, and one of those definitions included data. Let's just remember what that definition was exactly. Let me see here. Data. So the actual values of the variable. Okay. Um, so this would be the stuff like if you're doing an experiment, you would be collecting the data, right? So maybe it's like if you're taking surveys, the survey answers would be your data. So we're going to kind of focus on the data and look at, okay, what exactly is data? What are the different types of data? How should we gather the data? Okay. So a lot of the definitions in this chapter, I'm just going to kind of like breeze over because we're really looking at more of like the quantitative side of things rather than um focusing on um like this chapter is more about just like the definitions and stuff like that, whereas we really want to focus on the math, right? um So I'm just going to kind of glance over some of these definitions, but I encourage you to go through it and make sure you understand it at least. And if you don't, then come to me and we can go over it. Okay. And if you did take um, Math 101, you might recognize some of this from chapter 1 of that class, from the everyday math class. So the first thing that we need to talk about data are the types of data. Okay. And there's two main types. There's qualitative data, and quantitative data. Okay, so qualitative and quantitative. So, like I said, we're going to be mostly focused on quantitative in this class. Quantitative is the data that's more focused on numbers, the numerical side of things. Whereas qualitative data would be the data more focused on like characteristics, or things that you just can't really represent as numbers. So the way you handle these types of data are going to be vastly different, because with quantitative we can do a lot of math with it and a lot of tests that way, whereas with qualitative data we can't rely on any of those tests or any of the math, so we have to use different methods. But we're going, like I said, we're going to focus mostly on the quantitative because we're going to look at the math. So let's define these a little bit better though. Okay. So qualitative data are the result of categorizing or describing attributes. Okay, so the keyword here is attributes of a population. Okay. So we're categorizing or describing attributes, attributes of a population. And the book mentions that another word for this is categorical data, from this word categorizing here. So this would be stuff like hair color, right? Eye color, gender, grades in a class. Basically anything that we can't really describe numerically. Okay. So on the flip side, that leaves quantitative data to be the stuff that we can describe numerically. Okay. So quantitative data are the result of counting or measuring attributes of a population. Okay. So in both of these, we're doing something with the attributes of a population, but in the first one, we're categorizing or describing it. In the second one, we're counting or measuring it. So the word quantitative, it has the root word, or the prefix rather, quant, right? Like just like quantity. And qualitative has the root qual, like quality, right? So qualitative data is describing qualities. Quantitative data is describing quantities. Okay. And the book also mentions quantitative data are always numbers. Qualitative data could be numbers, but they're not numerical. So what do I mean by that? That goes back to like your survey responses, right? If you have survey responses like 1, 2, 3, 4, 5, 5 is strongly agree, right? Then our data are going to be numbers, right? Like say we have like 25s, 2 3s, and a 1, something like that. And our responses, they're numbers, but they're not like numerical. We can't meaningfully like add the numbers together or subtract them or multiply them or like anything like that. If we found the average of all of them, then we might get like 4.7, which is no longer one of our choices, right? So that wouldn't really make any sense. Um, Average in that sense, like meaning the mean, like we were talking about last time. Instead, this is qualitative data, so instead we want to find the mode, which that is what we'll talk about in chapter 2, so don't worry too much about that right now. But quantitative data is always numbers. Qualitative data, we could use numbers to represent it, but um it's not really numbers, right? The numbers are usually just placeholders. Like here, the 5 is just a placeholder for strongly agree. And the 1 is just a placeholder for strongly disagree. So they're not numerical. Okay. Now, quantitative data, we want to look at this one a little more closely because that's normally what we're going to be doing. We can break this down even further into two different types of quantitative data. I apologize if I ever spell quantitative wrong because um, it's just such a long word and there's so many T's in it. Sometimes I just write it fast and I just skip like the TI or the TA or something. So we can divide it into two different types. The first one would be discrete, and the second one would be continuous. Okay. So continuous means, in general, that you can represent it as one straight line, no breaks in it or anything. It's just one continuous line. Whereas discrete means it is kind of broken up like this, right? Um, so let me give you some examples. I don't think the book actually has any examples of this. Um, a good example of something in this discrete is something that you would just count, right? So just like numbers. So for example, if we want to look at the number of dogs owned by students at Simmons. Well, if we collected our data, right? Let's say this is this would be one dog, this is two dogs, three dogs. This is student A, this is student B, this is student C. Okay. When we collect our data, let's say student A has one dog, student B has no dogs, so 0. Student C has 3 dogs, etc. Okay. So our data looks like the discrete one, not like the continuous one, right? So this is a good hint that this is a discrete. This is discrete quantitative data. So this is discrete. So whenever we see the word number of, that's a good hint that it's discrete. Okay, anything that can be, if we go back up to the definition of quantitative, it talks about counting or measuring. In general, the counting part is discrete and the measuring part is continuous. Okay, so for counting something, it's going to look discrete, whereas if we're measuring it, it's going to be continuous. So, for example, um, say discrete, continuous. So discrete would be like number of, right? Maybe we don't really need this line. Number of counting. Um, Continuous could be something like height, right? That's something that we measure. Weight, that's something that we have to measure. Um, Time, that's a big one that we have to measure. Um, Length, okay. So we're not going to make a huge deal about the differences right now. That'll come more into play later. I just kind of want to mention them right now. But let's just look at example 1.9 in the book, and I'll write it down here too. Okay. So the number of pairs of shoes you own. We want to know, first of all, is it quantitative or qualitative? And second of all, is it discrete or continuous if it is quantitative? So the number of is what should give this away here. We're counting how many shoes we have, right? So this would be quantitative. I'll just write quant and discrete. Okay. Okay, B. The type of car you drive. Okay. So quantitative or qualitative? Well, we could just look at our data here, right? So type of car you drive, it's going to be like a Focus, an Escape, um, a Civic, a Corolla. They're not numbers, right? We're listing words. So that's a good hint that this is going to be qualitative. I won't do all of these. Let's just go up to C. Okay. So the distance from your home to the grocery store. Okay. Well, distance, that's something that we measure, right? It's not something that we can just count. So this is going to be quantitative, continuous. Okay. So I would encourage you to go through some more of the examples of the book just to really get a feel for this. I think once you do a few examples and try to like figure out whether it's quantitative or qualitative, and then if it's continuous or discrete, it kind of starts to make more sense. The reason I don't want to go too far into it is because we're going to be focusing almost exclusively on quantitative, and because we're going to be working a little more abstractly, we won't really have to determine if it's discrete or continuous. It'll typically be told to us this is discrete or this is continuous. Okay. So let's move on a little bit here. Um, so we'll just briefly mention the stuff about qualitative data. Okay. Um, yeah. Well, this isn't actually really exclusively qualitative data. This could really be qualitative or quantitative. So let's just we don't really have to call it quantitative or qualitative. Let's give it, that's just what the book calls it. So let's call it common types of graphs. Okay. So these are just some basic types of graphs that we could use to represent data, which I'm sure you've seen before. One of them would be the pie chart. Okay. The pie chart. So let's say we have, um, so in this example here, they survey people at this college and ask how many people are going full time, how many are going part time. And in their data, they come up with 40.9% as part time and 59.1% as full time. So the way we use this pie chart is we kind of break it up so that the percent that we have here lines up with the percent of the circle that we are coloring in that section. Okay, so here I'll color this in with purple. You can't really see the percent anymore, but that's okay. I'll use a lighter color for this one. And it still covers it up pretty good. So you can see the yellow part should take up visually about 59.1% of the circle. And the purple magenta part should take up about 40.9% of the circle. Okay. Obviously, we can't get this exact, but we want it to be roughly about that. Okay, so that's how we use the pie chart. Um, so I'm sure that this is nothing new, that you've at least seen this before. You know, if we have more quadrants like this, maybe this is maybe like 33%. This looks like it could be, I don't know, 42%. Now, one thing we need to be careful of is it does need to add up to 100, right? So far we're at 75%. So that actually makes good sense with how this is drawn, right? Because this is about 25%, and these look about even. So let's say 12.5% each. Okay. And then you could color these in, or you could just write the percentages. It's usually a good idea to color them in just so it's more visually appealing and you're able to, um, you're able to just immediately tell which one is bigger just by looking at it rather than having to read the percentages. Coloring it in helps that a lot. Okay. The second common type of graph we might see is a bar graph, right? It's another one I'm sure that you've seen at some point. So one thing that there's a few things we should always look at when we're making bar graphs, and really with the pie charts too. I kind of left it off there, but with the bar graph, let's go back to like the number of dogs, right? So on this side right here, this is the number of dogs owned. And here was the student, right? So we had student A, student B, student C, etc. And then here we have number of dogs owned per student. So when we're looking at these graphs, there's a few things that we should look out for. One, they should always have a title. Okay, if they don't have a title, then there's no way you can know what this data is trying to show you, right? Two, the axes themselves should have a title. Here I have number of dogs owned, here I have student. Okay. If these aren't labeled, then there's no way for us to know what is the independent variable and what is the dependent variable, which we'll talk about later. And I mean, it can just be confusing, right? Because you don't know exactly what this side is trying to tell you. You don't know exactly what this side is trying to tell you. Um, Also, the tick marks themselves should be labeled, which I didn't do here. If I don't have these labeled as 1, 2, 3, well, they could be 2, 4, 6. Like maybe we're counting by twos. It could be 10, 20, 30, right? There's no way for us to know unless at least a few of them are labeled. And same with these ones right here, which I did have labeled. Another thing we should look for is that the corner here should always be 0. Okay, we don't want 0 to be up at the top here or like where 1 is or something like that. Otherwise, it could be misleading. I think that's it. If you've had college algebra, or maybe it might have been talked about in Math 099, depending on how far your course got, you know that these are typically called the x-axis and the y-axis. Okay. So that's what we're looking at here. We usually only draw the first quadrant of the graph, the positive part, because with data, oftentimes that's all we really need. So we don't draw like the rest of it, like this part of it. Okay. So anyway, with the bar graph, we said last time student A had 1 dog, right? Student B has 0 dogs, so we just stay here. Student C has 3 dogs. So this is just another way of representing it. Before I was representing it as dots. This time I'm representing it as with these bars. So we just draw the rectangle up to whatever the data point is. Okay. It's maybe not the most useful for this data set. We could just as easily do this with dots, but this is one way to do it. So those are the only two I'm going to talk about right now, just because those are the two most common. You might have also seen like a line graph, and the book talks about what's called a Pareto chart. Okay. Um, but we're not going to get into those right now. So the next thing we're going to talk about is sampling. Now, so sampling is the way that we get our data. Okay. So this is how we get our data. How do we take our sample? Okay. There's a lot of different ways to do this. And the book goes through, I think, 6 different ways and talks about the advantages of each one. So I'll just kind of give some examples here to go over it. But at the end of the day, what we really need to make sure of is that um, our sampling should be done randomly. Okay. This is um, the biggest part. It should be a random sample. Okay. And so it should be done randomly, and the sample should be sufficiently large. Okay. So the sampling should be done randomly, and the sample should be sufficiently large. So what does sufficiently large mean? Well, it really depends on the context. Okay. Um, like for example, is 10 large enough? Probably not. Probably not in any context. Is 1,000 large enough? Maybe. It depends on the context. Okay. Um, it should be reasonably large. Okay. And it, but it should definitely be taken randomly. Now, with the large part, obviously some studies, there's going to be limitations. Just as an example, like at Simmons, we will often, every semester, we will ask students to fill out a survey about their classes. And, some semesters we've only gotten like 40 back or something like that out of like thousands that we should get back. That's not a sufficiently large sample, but it's what we get, right? So we have to deal with it. Does that mean that we throw it away and don't do anything? No, it doesn't. We still use the data. We just can't really make any conclusions based on that data or decisions based on that data, right? We can take it in, and then we just have to say, okay, this is what the data tells us, but we really can't trust it because we don't have a sufficiently large sample, right? So it's kind of like we still use it, but we have to give it that disclaimer. Okay. So whenever you're reading a study, you should always look for, at the end of it, it'll say something like n equals 250 or something like that, or n equals blank. Okay. So n represents the sample size. Okay. So n represents how big the sample was in the experiment. Okay, so if you look at a study, you should have somewhere in there it'll say n equals whatever number, telling you exactly how big the sample was. Okay, a capital N usually represents the population size. Okay. So remember, the population is the entirety of whatever you could study. The sample is what you actually do study. So the population size often actually probably isn't possible to know exactly what it is. Whereas the sample size, you know what it is because that's what you're studying. Okay. So in general, we would like little n to be as close to big N as we possibly can get it, but we probably can't always get it too close. Okay. So one of the types of samples that the book talks about is what's called a simple random sample. And that's exactly what it sounds like. It means you simply just take your sample completely randomly. So if we wanted to know, who was going to win the presidential election or who's predicted to win, the best way we could sample it is we could take a list of every single person's name and who they're going to vote for, and we could just completely randomize it, just take out names and do a whole bunch of them, and then look at what those results say. Okay. Obviously, that's not possible, so that's not what's done. So then we'd have to look at some of the other types of samples. Okay. So there's a whole bunch of them, and most of them are good samples, good types of sampling, but some of them are not. And one I really want to point out, I'm just going based on what the book is saying, is a systematic sample. This is a good example of a type of sample where you might think that it is a good way to do it, but it introduces what's called selection bias. Okay. So in a systematic sample, I'm sorry, not a systematic sample. A systematic sample is fine. I'm trying to think of the name for it. I don't think it's actually in this book. Um, Sorry, let me grab it from the other book here that I have. Just 1 second. What's the name? Quota sampling. Okay, quota sampling is a good example of a type of sampling that seems like it might be okay, but it's really not. So a quota sampling is where, we want our sample to be representative of the population. So say for example, I don't know the exact numbers, but say for example that like 70% of the population is Christian and 30% is non-Christian. Okay. Then if we were surveying 100 people and we intentionally picked 70 Christian people, and then once we hit 70 Christian people, we went over and intentionally picked 30 non-Christian people, then that's what we call quota sampling. So we have a representative sample, right? Because we have 70% of our sample as Christian, 30% is non-Christian. The problem is, if you remember here, it says it should be done randomly, and that's not really random. We artificially created this split with the Christians and the non-Christians, right? So it wasn't really done randomly. There's what we would call selection bias. If we actually do it randomly, we should get about a 70-30 split anyway, assuming those are the right numbers, right? Assuming that our sample is big enough. So there's something in probability called the law of large numbers, which in plain English, it basically says if your sample is random and if it's big enough, then it'll be representative eventually. Okay. That's not really what it says, but that's kind of how it would translate into this case. So I just wanted to point out that one in particular because it's a good example of where you think it should maybe be a good sample, but it's really not. All the types of sampling that they talk about in the book, with the exception of convenience sampling, are good types of sampling, assuming you're doing them randomly and you have a good enough sample. I know I'm not really talking about them. I just wanted to kind of mention them because, like I said, we're really just going to be focusing more on the math rather than identifying like the types of samples or anything like that. Okay. Okay. So let's move on to 1.3. Okay. Just see where we are in time here. About 37 minutes. There's not a lot I want to talk about in 1.3 actually. I mostly just want to talk about frequency tables, which is really something that is pretty natural that you'd probably do anyway without actually knowing it's called like a frequency table. Okay. So the frequency of something, it's exactly what it sounds like. It's how frequent is this particular thing. Okay. Let me get the book's word for word definition here. Frequency is the number of times a value of the data occurs. Okay. So, for example, if we have in a class, right, with the grades of a class, we have say like 12 A's, 8 B's, 7 C's, 3 D's, 6 F. Okay. Then the frequency of A would be 12, and the frequency of D would be 3. So it's just how many times does this one occur? Okay. Now, oftentimes, if we're talking about like, so if somebody asks me, like, okay, how many people in your class failed? And I say 6. And that's all the information we have. That's not really useful because, you know, if I have 100 students in my class, 6 of them failing, like that's pretty good, right? That's only 6% of them. Whereas if I have 10 people in my class and 6 people failed, that's 60% of them. So that's not good. That's over half the class. So the number itself is not usually too useful without any other context. So a lot of times what we're really interested in is what's called the relative frequency. Okay. So the relative frequency is the frequency relative to the total. Okay. So this would be the ratio of the number let me just say the ratio of the frequency, because it's just repeating the definition of frequency there, to the total. Okay. So when I say the ratio, I mean we're dividing. So we take the frequency and divide it by the total. Okay. So if we go back with the A, B, C, D, and F here, that bigger. So let's say, so this column is the grade column, right? Then let's make this one the frequency column. And then we'll make this one the relative frequency column. So what? We had 12, 8, 7, 3, and 6. If we want to know the relative frequency, what we need to do is we need to take the frequency and then divide by the total. Well, what is the total? Okay. The total is going to be 12 plus 8 plus 7 plus 3 plus 6. So we get 20, 27, 30, 36. Okay. So the relative frequency would be 12 divided by 36 for A, 8 divided by 36 for B, 7 divided by 36, 3 divided by 36, and 6 divided by 36. Okay. So altogether, this should add up to 1. If we want to, we could express this as a percentage, right? So this one would be 33.3 repeating percent. And you can just do it in a calculator. You can do 8 divided by 36 and then move the decimal place over twice. So we have 19.4 repeating percent. 2.7 repeating percent. And finally, 16.6 repeating percent. Okay. So if you add these all up, you should get 100% at the end. So instead of saying 6 people in the class failed, you can say about 16 or about 17% of the class failed, right? Which isn't great. So we know how to calculate the frequency. We just count the number of whatever it is we're looking for. For the relative frequency, we take the frequency and divide by the total. And then to make a frequency table, well, that's what we just did actually. So a frequency table is just a table like this one showing the frequency and usually showing the relative frequency. Okay. So there's some nicer looking ones in the book. Maybe you want to like connect these so it's like an actual table, right? Something like that. So yeah, this is how we make a frequency table. These are usually pretty useful just to get a sense of your data. Some of you guys took the sociology class last semester, which I was helping with Dr. C with, where we were looking at some data. And this is one thing that we did, right? We made a frequency table. So it was useful for that data. We were just looking at survey responses. It's useful for a lot of different types of data. Because one thing we can do, we're often interested in what the mode is, which we'll talk about later, but it's basically the average for qualitative data. If we already know the frequency, then all we have to do is look for the one with the biggest frequency, and that'll tell us the mode. Okay. I think that's actually everything in 1.3 that I want to talk about. So we can move on to 1.4 even, it looks like. Which again, there's only a little bit I want to talk about. There's in all of chapter 1, we're not talking about all of it. We're just talking about parts of it. So 1.4 is talking about experiment design and ethics. Okay, the ethics section, I encourage you to read about it on your own. The thing with ethics is it's not a universal thing, but there are like scientific standards of ethics that we should adhere to. But of course, everybody has their own types of ethics with how far they're willing to go with experiments. But there is like a line that, pretty much everybody agrees you shouldn't go past. Maybe others will have, their line closer, but you shouldn't have it further than that. So definitely read through that part. Um, I think the biggest thing is that, if you have like patients, like especially human patients that you're studying, the biggest thing is that they should, um, you shouldn't be risking their health. Um, and there should be what's called informed consent, which is that they need to be saying yes, but they also need to really know what they're saying yes to, right? You don't want to mislead them and then have them say yes to whatever you misled them with. You need to make sure that they really understand the risk. Not that they're like, oh yeah, that's fine. I don't really care. But they have to really understand what it is, what exactly the risks are. Okay. So that's what we mean by informed consent. And also the data you collect on them, it should be guarded, right? And there's usually laws in place like HIPAA, and with education, there's FERPA, those kind of laws that guard the data collection, right? Like in colleges, we have FERPA, which means I can't say what your grade is to other students or to other people in general. I can only talk about your grade with you, right? That kind of thing. So let's talk about some experimental design. Okay. So the different types of variables. Okay, so for 1.4, we're not really going to talk about any of the stuff in 1.4. The um the only thing I really want to mention here, let me just talk about a couple things here, is it talks about the explanatory variable. Okay. So this is basically your independent variable. Okay. So it's just, in the language of statistics is a little different than the language of algebra, right? But this is the same thing. And the response variable is the dependent variable. Okay. So your independent variable is normally represented with X. Your response variable is normally represented with Y. So if we go back to like our graph, where was that 1.2, right? With your X-axis and your Y-axis. So your X-axis is your explanatory variable, and your y-axis is your response variable. It doesn't really make sense in this context too much, the words explanatory and response, but essentially the explanatory variable is the one that's changing the response variable, right? And the response variable is the one that's like being changed. So if you're testing the effects of vitamin D on brain health, for example, then the effects of vitamin D is your explanatory variable. It's the thing that's doing the changing. Your brain health is the response variable. It's the thing that's being changed. Okay. So that's just a quick explanation of that. The other thing I want to talk about is that in general, we should always be trying to make sure that our experiments are what's called a double blind experiment. Okay. Want a double blind experiment. And when we're looking at studies, we should also be checking whether or not they were double blind studies. Okay. So double blind, this means that you have a control group and a treatment group, where the treatment group is given whatever it is you're testing, and the control group is giving what's called a placebo, right? So it's like a sugar pill or something that it mimics whatever it is that you're studying, but it doesn't actually release the same effect, right? So if you're studying like a new drug, then a common placebo would be a sugar pill that looks exactly like the new drug. Okay. So you have your treatment group and your control group. In a double-blind study, neither group knows um, which one they are getting, and the person administering it also doesn't know what they are giving. Okay. Only the researchers or whoever know that are distributing it to like the nurses or whoever are the ones who know who gets what. Okay. But neither group knows, and the people directly administering it don't know either. So, this is ideally what we want because we want to rule out the possibility of a placebo, right? Because placebo is very powerful and it can interfere with the results. So, we need to always be accounting for it. Okay. So, there's other things they talk about in 1.4. It mostly just goes more into depth of what I was just talking about. 1.5 and 1.6 aren't actually new material. These are just kind of like experiments for you to do on your own. Um, so these are things like that maybe I would come up with like homework problems out of, or maybe discussion questions, but not something we're going to talk about in lecture. So next time we're going to start on chapter 2. We're going to, we first just talk about a bunch of different types of graphs. We're looking at what's called descriptive statistics, if you remember from chapter 1. So like just describing the statistics, not really making conclusions yet. So first we're going to look at a bunch of different types of graphs. Then we're going to look at calculating averages and let's see. Oh yeah, and then variability. So we're going to talk about like standard deviation and variance. And I think that's pretty much the gist of it. So yeah, let me know if you guys are having any questions, and I will see you on the next one for chapter 2. Thanks for watching.